In 8.5, we're going to study rhombi, squares, and kites. A rhombus is a quadrilateral with 4 congruent sides. Unlike a square that has 4 congruent sides and 4 right angles, a rhombus has 4 congruent sides but not congruent angles. As you can see in the picture here, the opposite angles are congruent, but they are not all congruent to each other. So a rhombus shares the characteristics of a square and a parallelogram. A square is a quadrilateral with 4 congruent sides and 4 right angles. It is similar to a rectangle in which it has 4 right angles, but it also has the very important characteristic of 4 congruent sides. Let's look at what we know about quadrilaterals. We have a Venn diagram here. As we look at the Venn diagram, we have a rectangle that represents every possible 4-sided figure, all the quadrilaterals we know that exist. Inside of that, we have the yellow circle or yellow oval, which represents all parallelograms. You notice if an object is a parallelogram, it also could be a rhombus, a rectangle, or a square. We would say that a square, which is the intersection right here of the pink and blue circles, squares would be a rectangle because it's included in the blue oval. It's a rhombus because it's included in the pink oval, and it is also a parallelogram. So a square actually has 4 different names. A square can be called 5 names. A square would be called a quadrilateral, a parallelogram, a rhombus, and a rectangle. A rhombus, on the other hand, only has 3 names. It's a quadrilateral, parallelogram, and rhombus. There is the special case when it is a square, which makes a rhombus turn into a rectangle at that point. But that's the only time a rhombus would be a rectangle, is when the rhombus was actually a square. Now we have 2 more types of quadrilaterals that are not represented by this Venn diagram. They are the trapezoid and the kite. We'll talk about the kite in this lesson, and then the trapezoid will be in our next lesson. A kite is a quadrilateral in which 2 pairs of adjacent congruent sides, or there are 2 pair of adjacent congruent sides. If we look at the picture on the left, this side and this side are congruent to each other. If you think of a kite, it would be towards the front of the kite, and then the 2 sides in the back, or the tail area of the kite, would also be congruent. We also have that the diagonals are perpendicular. So when I create the 2 diagonals, they make 4 right angles in the center of the figure. There are a few more characteristics, as you can see. The opposite angles, which we would kind of consider the sides of the kite, are congruent to each other. However, we cannot say the same thing about the 2 ends of the triangle. The end on the left and the end on the right are not congruent to each other. We can never say that. The 2 ends of the kite will never be congruent to each other for their angles. The side angles could be, but never the end angles. The other characteristic is that the long diagonal here bisects the short diagonal. So these 2 pieces are equal in length. However, it is obvious that the long diagonal is definitely not congruent to the short one. They are not the same length. A couple more characteristics about a rhombus. If a parallelogram is a rhombus, in other words, if we have a rhombus, the diagonals are perpendicular. This is only true when we have a rhombus. All rhombi diagonals intersect at right angles. This is not true for a parallelogram. It is only true for a rhombus. The diagonals are perpendicular to each other, which means it is also true for a square. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. What happens in a rhombus then is the diagonals, as they go across the figure, bisect the corner angles. And it actually ends up creating 4 congruent angles. Same thing with the other diagonal. It creates 4 congruent angles. The last part of our lesson, and this will actually be part of your test as well, is we're going to give you some coordinates, and we want you to be able to identify what type of parallelogram is the following coordinates, or do the following coordinates make. So in order to determine what kind of parallelogram this is, we need to figure out the slopes for all of the sides of the parallelogram. So I've just put the coordinates in order, starting at any corner. It doesn't matter which corner you go from. So what we want to do is we want to calculate the slope. So I'm going to do the top side. I'll call it side number 1. Remember, to do slope, we subtract the y's. So 2 minus negative 1, which would be 3, over 3 minus 2, which would be 5. So the top side has a slope of 3/5. Let's go to the bottom side. We subtract our y's. 3 minus 2 would be 5, over negative 1 minus 2, which would be negative 3. Now let's do the other two sides. So we're going to do the right side. I'll call that side 3. So we subtract the y's. 3 minus 2 is 1, over negative 1 minus 3 would be negative 4. Then we go to the left side. We do negative 1 minus 2 is 1, and negative 2 minus 2, which would be negative 4. So as we look at this, we have one pair of opposite sides parallel, and that's all we have. What shape has one set of parallel opposite sides? Your answer would be a trapezoid. The only figure that matches the given characteristics is a trapezoid. If you have questions in this lesson, please make sure to stop in and ask, or grab me during class or in the hallway, and I'll answer any questions you might have. It's not